So we looked at the modulus function, we looked at what it meant, how to represent it, and how to sketch it. So what I'm going to do is I'm going to give you a couple of examples here, just of looking at sketching the modulus function. What I'd like you to do, read the questions, pause the video, have a crack at them, come back and check your answer with the solutions I'm going to post as well. So here you go. What I'd like you to do is sketch the graph of f of x and the modulus of f of x for each of these two functions. So f of x equals x squared minus 1 and f of x equals ln x for x greater than 0. So pause the video, have a crack at these. So the two questions we asked, f of x equals x squared minus 1 and ln x where x is greater than 0. So if I want to look at sketching f of x first for the x squared minus 1, well, I know what the graph of x squared looks like. The only difference is I'm now adding in a minus 1. So all that's going to do is shift the entire graph down by 1. So I'm still going to get the exact same sort of shape here. The only difference is it's going to move it down to minus 1 there. What I'm also able to do is look at some key points of interest, namely the x-axis intercepts. So for that, I know that f of x has to be equal to 0. So I'm looking at where x squared minus 1 equals 0. And for that, I know that x is equal to plus or minus 1. So positive or negative 1. So it's going to cut there at 1 and there at negative 1. So that's what the graph f of x equals x squared minus 1 looks like. What I now want to be able to do is plot the graph y equals magnitude or the modulus of f of x. Now bear in mind that we said this rule was quite simply reflect it in the x-axis. So it's going to have the same shape, it's going to still come down, except the only difference, when I hit the 1 for my x-axis intercepts, I'm going to come down here, when I hit the 1 and the negative 1, where it goes below the x-axis, instead of continuing below, what I'm going to do is reflect up and go back up that way there. So it's going to look something like that. Now the key thing as well at this point is we have to make sure we see and mark on how any key points of interest have changed. Now the only one that we're looking for is this one here. So cut the y-axis at negative 1. To reflecting up, it's now going to cut at 1. That there is a sketch of y equals the magnitude of f of x for this curve here. Second one was f of x is equal to ln x, where x is greater than 0. So for this curve here, I know all that's going to happen is if I label this as my x-axis, let's label u as my f of x, I'm only going to have positive values of x. So I'm only going to take those into account. Now the graph of ln of x, we know, looks like that, goes along those lines there, and it cuts at x equal to 1. So that there is a rough sketch of y equals f of x. Now in order to then be able to calculate this and look at the magnitude of f of x, I follow the exact same logic here. Anything below the x-axis, I just reflect up and above it. The only time it goes below is when x is less than 1. So what I do is I do the exact same curve from 1 going all the way up there. All I do then is take what was below the x-axis and just simply reflect it up. Now a key thing you need to make sure when you're looking at this is that you never ever cross the f of x axis. If you were to remember and look at the ln x, if you were to take any value of x below 0, you would never ever get a solution. So it would never ever cross this axis. And that is the same and holds for the magnitude of f of x. We have to bear in mind rules like that don't change. All that happens is the graph is reflected. So there you go, there's your two sketches, x squared minus 1, ln x. Just remember those key points. Sketch the original curve and just look at points where it cuts the x-axis and goes below it and reflect it up. Mark on any key points and information so that you can then show, right, I know how this has changed and I know exactly what's happened to the key points that are on the curve and associated with the original.